recording. There we go. We are recording now. Okay. That way you
Okay.
can go back and look at this later, or if somebody else wants to look at it, they can see it too. Okay.
Okay.
So let's go back to our sharing here. My bad. There we go. Okay. So this is problem 1 from section 4.1 we're working on, right?
Yes.
Yeah, I forgot to write that down. So let's put that down. So this is number 1, and we are in section 4.1. Okay.
4.1.
All right, so I'm gonna let you go ahead and write the sentence, but that's the height of Lake Powell after 2 years.
Okay.
Okay, so let's go take a look at E4. So that's going to be the height or the elevation of the lake after 4 years, isn't it? Right?
Yeah. So then you would do the same thing, but multiply by 4 instead of 2. Yeah.
You got it exactly. So that was meant to be an 8 there. There we go. Good recovery. Minus 77.2 times 4. And again, explaining the meaning of my answer, that's going to be the elevation of the lake after 4 years.
4 years.
I think part of why Lake Powell was dropping so quickly too is I think it was Las Vegas, one of the major areas, and they were sucking water out of it too.
Why?
Why do we have a city in the desert? Tell me that.
I used to live there, so yeah.
We have all these
a lot of
water features. I mean, and misters and
all the Hoover Dam,
Oh yeah, we don't need the water. Jeez. Okay, so the surface elevation of Lake Powell increasing or decreasing, and how do you know? All right, so there's 2 ways you can answer that one. Well, we know it's decreasing, and you can see
decreasing.
Yeah, you can see the numbers, right, that you've got here in part B and C.
Mm-hmm.
But there's another way of thinking about this. We can rewrite E of t in y equals mx plus b format. In other words, we can put it in slope-intercept form.
X plus b. Okay.
And we know that when m is less than 0, in other words, when m is a negative number, then we're decreasing.
Yeah, decreasing.
Yeah, when m was greater than 0, then we know that what? We're increasing, right?
Yeah.
Okay, so if we take our original E of t and we write it in that format, it's negative 77.2t plus 3,861. And you go, oh, but of course. That's m, isn't it?
Negative.
Yeah. It's negative, so we're decreasing.
Because it's negative.
So Jessica, can you give me a specific problem from chapter 5 that I can work on for you?
The one that I had problems with and I uploaded it just halfway filled out was in section 5.1, I believe, and it's the last number 9. In
5.1 proper?
Yes.
Okay.
I believe so.
Okay, so that would be 5.1 from the practice problems, because 5.1 only goes to 6.
Okay. It cut off the number when I scanned it. I don't have my paper in front of me. Maybe it's 6 then, because I have 4 and then the last page.
Okay, that's the one that says, given the following table, explain why the data can be best modeled by an exponential function. Use the idea of common ratio in your response. Determine the exponential model that fits these data. Determine f of 10. Determine f of 50. Does that sound right?
No, that's not the one that I'm looking at.
It's not. Okay. So
I have that one done. I think it might be it's not the U-try, it's the actual problems, and it's
so from the practice problems.
Yeah, it's number 1. It says nope, that's not number 1. It doesn't have the number, but it's after number 4 on the practice problem.
Okay.
Sorry, I don't know why it's scanned really weird, and my paper is in my bag at work.
Oh, no worries. So number 5 is complete the following table of exponential functions.
Right, and that's where it asks for like the base and domain and range and horizontal intercept, and then the
vertical intercept and the horizontal asymptote, increasing and decreasing growth of decay.
The one word I can't ever say. I looked over the mini lesson, and I looked at different videos, and I even Googled some other stuff, and I just could not quite understand how to figure out both of the horizontal things.
It's so easy, it's hard.
Okay.
It really is. It's one of those ones that's so easy, it's hard. Okay, so hang on just a sec. I want to copy this over. I got to shrink it a little bit to make it so it's going to fit. So give me just a second here. Hopefully I'll keep it big enough that we can see it on the slide here. Okay. So a fresh page. Ooh, I may have shrank that too much. let's try that again. All right, hang on just a second. Let me make it a little bit bigger back over here. Yeah, that was going to be kind of tough to see. Yeah. Part of the problem is I got to shrink it enough that I can see the whole thing so I can copy it. It's just so much easier for me to work on. This is just a simple paint program. It's, you know, just way easier to draw on than drawing on the PDF directly. So I get colors, I get all sorts of good stuff. So I prefer to do it over here. There we go. That's going to work. Okay. So can you see okay?
Yeah.
All right. So this, when you get rid of that, I don't want you. I want you to go away. Okay, so if we take a look at this, we've got all these three different functions, right? And then they ask us, you know, all the grundle of information about each of these three functions.
Mm-hmm.
Okay, so the initial value, let's talk about that one first. The initial value of the function, the way to think about that, I mean, they give you a hint that it's the value A.
Right.
So look, you know, you got f of x is equal to a times b to the x, right?
Mm-hmm.
But to make sure you really understand what's going on there, initial value means x is equal to 0. So time is equal to 0, what we started off with. And so if you look at that from the mathematical standpoint, f of 0 is going to be a times b to the 0. Well, b to the 0 is always going to be equal to 1, so you get back a.
Mm-hmm.
So that's it's pretty easy on here. You just come in and grab that number, okay? So that's 3.4, right?
Which is what I had, yeah.
Sweet. Okay, and then the base, well, that's b, so that's 1.13.
Mm-hmm.
The domain on all exponential functions is from negative infinity to positive infinity.
Okay.
There's nothing you can put into an exponential function that will cause it any sort of grief. So you can go from negative infinity to positive infinity in all of them. And that's going to be the same straight across. These are all got the same domain.
Okay. I wrote it wrong then. I said like y is greater than 0 when we're solving f for x.
Well, I'll tell you what, this is a good way of trying this is do this. Put it in your calculator, go into Y1, and put in 4, parentheses 1.13 caret x. And you take a look at the graph of that. You can end up with a graph that looks not quite unlike, but similar to that.
Okay.
Where that point right there, that's going to be at 3.4. That's at 0 by 3.4.
Okay, that makes sense. Thank you.
Yeah, and so, but look, it's going, where are we going? Oh, we're going down to negative infinity, and where are we heading this direction? We're going to positive infinity, aren't we?
Yeah. Okay.
Right, but this is going to help us out with the next two questions too, which is, well, actually, we'll skip a little bit. It's going to help us with these two. Let's do these two first, and then we'll talk about the horizontal and vertical intercepts, okay?
Okay.
All right, so the range. So one way of thinking about the behavior of this graph as it's heading out towards negative infinity is that it's kind of like, have you ever been to Trinidad?
Yes.
Okay, so if you go to Trinidad in the summertime, there's all these sparrows, you know, these birds that come there.
Mm-hmm.
And the road that goes down to the beach, down to the seascape, you know, if you go down to the beach there,
yeah,
if you watch those birds, they fly and they get super close to the road. So like this is the road right here. The birds, they'll fly like, you know, here's my bird, there's the wing. Okay, I'm a lousy artist, sorry. But they come down and they get closer and closer and closer and closer to the road. But do they ever touch the road?
no.
No, that would be bad, wouldn't it, right?
Yeah.
It'd be like shredded tweet, right? It'd be horrible. So that's exactly the behavior of what's going on with this graph as you head towards negative infinity. It gets as close to the x-axis as you ever could possibly want it to get, but it never is going to touch it.
Okay.
So what that means is that we will never get to the x-axis. We'll get really, 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 really close to it, but we're never, ever going to touch it. So since we're never, ever going to touch it, that means that y is never going to get all the way to 0. So thinking about this in terms of the range, if we go back to the earlier lesson, what that means is that we're going to start down here with an open dot, and we're going to go up that way on the y-axis. Just to be complete, I'm going to go ahead and put the domain in here under this red line. So the red line is all the possible x values that I can do, which is negative infinity to positive infinity, including, you know, we go through the origin. And then the blue line is going to be my range. And so notice that my range here is going to go from 0 to positive infinity.
Okay.
All right, so let me do these in inequality notation just so we can see it. It's also would be, you could write this as negative infinity is less than x, which is less than infinity. And on this one, you would just write y is greater than 0.
Okay.
All right, so horizontal asymptote. Well, what that means is this behavior, that bird coming down and getting as close to the road but never touching it. That's the idea of an asymptote. You can get as close as you want to it, but you're never going to go through that. And so in the case of an exponential, the x-axis is your horizontal asymptote.
So that means that that's negative infinity?
Well, actually, it's way more simple than that. All you want to tell me is what is the equation of that horizontal line? In other words, what's the equation of the x-axis?
Well, there's never any point on it, so it's just 0?
It's x equals 0.
Okay. Well,
oh, wait. Time out. Sorry. Y equals 0. My bad. Excuse me. Replay that tape. It's y equals 0. It's the equation of a horizontal line. Here, let's do a quick review, okay? So let's say this is my x, right? This is my y, and I got a horizontal line passing through 5 on the y-axis. Well, the equation of that horizontal line is y equals 5, isn't it? Okay, cool. All right, so I got a horizontal line passing through 0, right?
Right. So, okay.
So the equation of the horizontal line is y equals 0.
Great. I really made it way more difficult when I was reviewing all of that during the lesson.
There's an old saying that only 2 types of mathematics, impossible and trivial. Once you get it, totally trivial. When you don't get it, it is impossible. Okay? Okay, so let's talk about these intercepts. Let's come back up to those. All right, so the horizontal intercept. Well, we just said it doesn't hit the horizontal axis, so there's none.
Okay.
Right? And then the vertical intercept, well, we already sort of figured that out when we did the initial values, just we didn't report it back as an ordered pair.
Right.
And so that's going to be 0 by 3.4.
Great, I got that right.
Nice. Okay, is this one increasing or decreasing?
I said increasing.
Sehr gut, ja, das ist ganz gut. Okay, and is it growth or decay?
The growth.
Yes.
Yay, okay, well, thank you.
All right, you think you can do the other ones now?
Maybe.
Well, let's do a quick check here, all right? Let's just we'll hit the hard ones, all right?
Okay.
Because I think you got all the other one, all right? So tell me about the range on g of x.
Oh gosh. Well, it's going to be the same, right?
Yes. What about h of x?
Oh, it cut me off on that one. What does this one say? It's going to be the same as well.
Yeah?
Yeah.
I put smiley faces to mean you're right, okay?
Okay.
Okay, what about the horizontal intercept?
Well, there's not going to be any.
You got it.
Okay.
Those are all going to be the same too. Okay, vertical intercepts. Okay, so that's going to be, tell me what the vertical intercept is for g of x.
0, 42.
You got it. Good job.
And then 0, 1000 on the next one.
Yep, exactly. Okay. What about the horizontal asymptote?
Will it just be 0 again because it doesn't go through?
Yep.
Okay. And then on the second one, I said that it was decreasing.
Correct. And the reason it's decreasing
it's under 1.
You got it, because 0 is greater than b, which is less than 1.
Right.
We have a fraction.
I remember that.
Good job. Okay.
And then the last one is increasing, but barely.
Yeah. That's okay. It's just got to be bigger than 1.
Yeah.
And remember that increasing goes with growth and decreasing goes with decay.
Yeah. Great. Thank you. I'm glad that I hopped on and asked about those couple of things.
Not a problem. Not a problem. This, don't be shy about taking advantage of these office hours. They're for you guys to get just for that sort of thing, because it's usually one little thing that's stopping you from succeeding.
Yeah. Thank you.
You're welcome. Okay. All right, we're back. This is what are we going to do some more from chapter 4?
That'd be awesome.
Sweet. Okay, let me just go ahead and get rid of this one window here. And let's go get another fresh one. Okay, so what would you like to do from chapter 4?
I guess. Okay, so I have it circled the it's now 4.2.
Okay.
It was one that you wanted us to do, so problem 4. But if you want to do problem 3, so that way.
Let's do one that I assigned, because we're in after the fact now anyway.
Okay.
So it's not an issue. Let's do one of the ones that was on the homework. That's fine.
Okay.
Okay, why is it? All right, never mind. Okay, so which one are we working on?
Problem 4 on page 136.
Problem 4 on page 136. Okay, sorry for being
and
a little
it's
dense.
No, it's fine. I'm the one that's delayed.
All right, cool. So we got to determine if this thing is linear, right? Isn't that what the one they want us to do?
Yeah.
All right, let me go grab it real quick. All right, so that's the one right there, yes?
Yes.
Okay. All right, so for each of the following, determine if it is a linear function. If it is linear, give the slope. Okay, so how do we determine whether or not this is a linear function or not? Well, there's several different ways, but the easiest way is that if it's a linear function, then what that means is that you're going to have a constant slope, okay?
Mm-hmm.
If we're lucky, and they give us like 1, 2, 3, 4, et cetera, straight across, and give us a constant interval between the x values,
mm-hmm.
then it's relatively simple to do. But since they didn't do that, we're going to have to do a little bit more work, okay?
Okay.
There's a couple different ways of doing this, but I think we'll go with the easiest way, which is just calculate the slope between any two set of points and see if we keep getting the same slope or not, all right?
Okay.
Okay. You ready?
Yeah.
All right, so the slope is m is equal to y2 minus y1.
y1.
Yes.
Okay.
x2 minus x1, right?
Yeah.
Okay, so I think to help us out here, make this go a little bit faster, we're going to get the calculator out, okay?
Okay.
So let me get mine going here.
I think I just sort of gave up before I went on to this. And that's why.
Right, you probably could have done this just fine because this is pretty straightforward.
I see it now.
Okay, so let's go ahead and let's give it a go here. So for our
Okay.
first order pair, we'll call this one here. This will be our x1. This will be our x2. This will be our y1.
Y1.
This will be our y2. Okay.
Okay.
All right. So on the calculator, I'm going to go parentheses, and I'm going to go 347 subtract 491. I'm going to close the parentheses, do a divide. Let's open parentheses, and that's going to be -2 subtract -5, and then close the parentheses. And then I'm pretty sure it's going to come out to be a decimal. So to make my life a little bit easier, I'm going to press the math key. And the first option in the math key is to give it back to me as a fraction. No, it wasn't. Never mind. Okay, so I got back -48. Okay.
Yeah. Okay.
All right, cool. All right, so let's go try the next set of values here. And so when we do that this time, we're going to change the starring roles here, all right? So let's take a look at the next ordered pair, and we'll call this one x1, y1, and we'll call this one x2, y2, okay?
Okay.
All right, so let's see what we get this time. So we're going to go parentheses 203, and then we're going to go ahead and subtract from that 347. And then we will divide that by parentheses 1, subtract -2. And it looks like it's -48 again, right?
Yep.
Okay, so I'll let you keep going, but I'm guessing that it looks like we're going to keep getting the same.
-48.
Yeah, we're going to keep getting -48, aren't we, right?
Yeah.
Okay, so what that tells us is that m is equal to -48. Now, you really do need to check them all because it could mess with you with like the last set of ordered pairs, right? That would be
sure.
rude to them, but they're mathematicians, okay? Is that making sense?
That part looks pretty straightforward. I think I'm okay with that one, and I can work on that as well.
Okay, so the rest of them, same thing. Okay,
okay.
It's a bit of grunt, but it's not horrible.
No, I like I said, I just sort of gave up, and that sucks.
I'm glad you've ungiven up. That's a good thing.
Yeah.
Okay, so did you get a chance to watch the media example yet on problem 5?
No, I did not, but I will.
Okay, cool. Because they'll show you how to do that one, so you can just go ahead and do that.
Oh, okay, yeah, because it has the media example.
Okay, how about problem 6? That's the U-try. Should we go ahead and take a look at that one?
Sure.
All right, so let me go make a copy of that. I'm just going to go ahead and reuse this one. Okay. What do you think? Are we on the good one here? This is the 5-week diet program, right?
Yep, that's it.
Okay, cool. All right. So first thing they want us to do is identify the vertical intercept. So again, remembering what they mean by the vertical intercept is that this textbook, they're kind of unique in this. This is the first book I've seen that's done it this way. They're saying that's a horizontal line, that's a vertical line. So the vertical intercept, that's going to be the y-intercept.
Okay.
And what we know about the y-intercept is we know x is equal to 0. So down here, this is the horizontal intercept, better known in most books as the x-intercept. And what we know about that one is that y is equal to 0 there, okay?
Okay.
That's a good thing to keep in mind. All right, so let's go back and take a look here. Oh, wait, t is playing the starring role of x now, right?
Mm-hmm.
And w is playing starring role of y. So my x is 0. Ah, there we go, 0 by 196. So that is the vertical intercept. Just got to read it off the table. Is it making sense?
Yeah, that seemed a little too easy.
Yeah.
Oh, stop.
Well, no, it's the thing is, like I just said, if you get it, it's totally easy, right?
Yeah.
Otherwise, it's in Swahili.
Well, yeah. And it might be still for me, but
That's okay. It's going to come, though. You got to have faith in yourself that if you just keep plugging away at the stuff, it's going to make sense.
yeah. Okay.
All right, so we wrote the ordered pair, and then they want a sentence
Right.
explaining the meaning of the situation. So what that means at time 0, so when they first started this diet, right?
Yeah.
At time 0, or I think it's week 0, right? Or you could say at week 0, the weight is 196.
At week.
I would love to weigh 196. I weigh about 210 right now, so and that's about
196.
that's a little more than I should weigh at the moment. That's okay.
The camera adds.
Yes, there you
right?
go. Exactly. Okay,
The
so
average
compute
rate
the
of change.
average rate of change for the 5-week period. Be sure to include units.
Mm-hmm.
Okay, so what we're going to have to do is go in and calculate the slope. So a key thing here is when you see average rate of change,
Mm-hmm. That's the slope.
it's the slope. This
So that's
word,
the m equals
yes,
y2 minus y1.
yes,
And then, okay.
yes, exactly.
Okay.
Whenever you see the word rate,
Uh-huh.
you want to think slope.
Okay, rate. Think slope.
Yeah, they're pretty much interchangeable with each other.
Okay.
Okay,
So then I have to do that 5 different times. right?
Well, if it's linear, it's gonna stay the same. Okay, if it's exactly linear.
Oh, if it's linear. Oh, okay.
Right, and if
Okay.
we take a look at this, it's not gonna stay exactly the same slope every time. They were kind here because it went from 0 to 1, and then 1 to 2, and then 2 to 3, 4. Right, so we know that the x's are going to be the same every time, right?
Right. Okay.
Okay. So one way of there's a couple of different ways of talking about the average rate of change, but probably the easiest way going to be to do this is to take the first ordered pair right here and call this one x1, y1, right?
Mm-hmm.
And take the last ordered pair here and call this one x2, y2. And that's going to be the average over the 5-week period.
Okay.
Is that making sense?
Yeah.
Because that's what they want to know. They want to know the average for the 5-week period, right? So we take
Yeah.
our first week and we take our last week. If you go through and you take every one of the order pairs like we did in that previous
In the
problem,
first one. Mm-hmm.
right? They're not going to be the same slope every time.
Okay.
So that's why they're saying we just want to know what the average rate of change is over that period of time.
Okay.
Okay, so
Okay, because that said for the average rate, and this one said for each of the following, determine if the function is linear.
right,
Okay, so they're asking for 2 different things.
right.
Yeah, okay.
Okay, so let's go ahead and do that. Let's go ahead and run through it.
Okay.
So that's going to be 186 minus 196
196.
divided by 5 minus 0.
5 minus 0. 10 over 5. So 2.
Yeah, but hang on. It's what? It's -2, isn't it?
Oh, yeah. Uh-huh.
Right?
Yeah.
Okay. And so they said be sure and include units. That's probably why I wanted to do it. So if it's -2, well, what's in the numerator? What are the units in the numerator?
-10.
Yeah, I'm with you.
And
You got
then
-10
over
over
5.
5, right? Yeah,
Mhm.
but what's, remember that the y's,
Oh, time and then pounds.
right,
Weeks,
exactly.
Weeks. Okay, yeah.
Okay. So the numerator, that's in pounds, isn't it, right?
Yes,
Because remember the y's were pounds, weren't they?
that's right. Yep.
Okay, and so that's -2 pounds per one week. So it's saying you're losing 2 pounds per week.
Oh, wow.
On average, over the 5-week period, they lost 2 pounds per week.
Okay.
And that kind of makes sense. So look, in the first week, they lost 4 pounds, but the next week, they only lost 1 pound, right?
Yeah, and then they lost 0.
Then they lost, between week 3 and 4, nothing. They were holding, right?
Right.
And then they got on that exercise bike, and
yeah, they were like, wait a second.
yeah.
Okay.
And they dropped some more. Okay.
Okay, so then I have to write a sentence on the other one. I could do that because you just sort of did it.
They want you to take down and explain what you just did here in part C. So what does that mean? That means on average they lost 2 pounds per week.
Yeah.
Okay, so, and then this is the perfect linear function. So that previous problem that we did, the very first one that we worked on, that was perfectly linear because we kept getting the same slope no matter which 2 order pairs we picked.
Right.
In this case, that's not true. The slope's changing depending on which 2 order pairs we pick, right?
Mm-hmm.
Okay, so this is not.
No, it's not linear.
It's not perfectly linear.
Not perfectly linear. Okay.
Yeah, if we plotted this kind of like what we do later in this chapter where we do a scatter plot, we'd see that it looks pretty linear. It just doesn't fall all exactly on a line. And in the real world, that's how it works out. I mean, when you get real world data, it's not going to fall exactly on a line. It's going to be close to it, but it's not going to fall exactly to it.
Right. There's going to be that decimal point things.
Yeah, this would be a little above, a little below, and so you're going to go these crazy decimal points when you do the regression.
Okay. And I have to get going. I have to put my daughter to bed, but
Okay.
I have a quick question about, there was an email sent at the beginning of the semester about turning in the paper with a scanner thing, CamScan or something.
Yes.
Okay, I use CamScanner on my phone.
Yes.
Is that okay, or do you want me to try to fax it? Okay, all right.
No, CamScanner I want you to use a scanner. I want you to use a phone scanner. That's totally what I want. The only problem is some folks with the scanner were turning in 14 pages or 15 pages.
Right.
Okay, so the scanner, if you go through the tutorial on the scanning utility, it allows you to put all of the pages into one document. So you don't have to do 14 uploads.
Okay, yeah, right. Okay, yeah, mine does it automatically.
Yeah, then you're good to go. Then then there's nothing to worry about. I mean, I've been getting some people who have been giving me
14 different uploads. Okay, I got it.
Like 15, 16 JPEGs, and then
at least are they upside down?
Sideways.
Yeah, I heard that ours in the nursing program, some of the ones that people were turning in were upside down. So the instructor got really mad at us. So I kind of learned how to do it from there.
Good. Well, I'm not getting mad at anybody. I've been reading homeworks like this, let me tell you.
Oh, wow, that's very nice of you.
Well,
thank you.
I mean, the math's hard enough. I know the technology is just making it all that much more difficult at times.
Yeah, and it doesn't really help. I'm not very good at technology either.
You're doing great. You're doing really good. I mean, we pulled this off, and you're doing good with that.
All right.
Here's what we need to do. I have another office hour on Thursday nights that I do.
Okay.
That's for my stats class. You'll have to wait for a lull, but I'll be happy to answer questions for you. So what you got to do is Thursday, ask me for an invitation, and I will send you a link to get into the office hour because that's their office.
Oh, okay, sweet.
Thursday.
I'll probably be taking that next semester if I do get on this one. So.
Okay, cool. And then so
Thank you.
The other one is I can arrange, you go try working some on your own, and we can do, tomorrow night's booked, but I could probably do one over the weekend too, okay?
Oh, okay, cool. And the tutor that I have is through the TRIO program at Del Norte.
Nice.
And she said that she's pretty open to my schedule. So she said she could help me Friday, Saturday, and Sunday.
Perfect.
Get caught up. So
Perfect.
Okay, awesome. Thank you very much.
Perfect. Keep the faith. We're going to get you through this, okay?
I'm going to try. Thank you.
All right. Okay.
Okay.
Talk to you soon.
All right, bye.
Bye-bye.